In the year 334 BCE, a young king stood at the edge of the known world, staring across the narrow waters that separated Europe from Asia. At just 20 years old, Alexander of Macedon was about to launch the most audacious military campaign in human history. Behind him stretched a column of 43,000 infantry and 5,500 cavalry, the most formidable army Greece had ever assembled. Ahead lay the vast Persian Empire, a dominion that stretched from the Mediterranean to the Indus River, ruled by Darius III, and defended by armies that outnumbered his own by staggering margins. Most generals would have seen this as madness. Alexander saw it as destiny. What followed was not just conquest, but a masterclass in military engineering that would reshape the ancient world forever. In just 10 years, this Macedonian king would build an empire larger than any before it, stretching across 3 continents. But here's the secret that most people miss about Alexander's success. It wasn't just his courage or his tactical brilliance that carved out this empire. It was something far more revolutionary. Something that would fundamentally change how wars were fought for centuries to come. Alexander had weaponized engineering itself. While other armies relied on brute force and traditional battlefield tactics, Alexander brought with him a terrifying new arsenal of siege machines, combat engineers, and tactical innovations that could reduce the mightiest fortress to rubble. Cities that had stood unconquered for centuries fell to his advance in mere months. Walls that had protected civilizations for generations crumbled before his mechanical marvels. But this wasn't just about bigger catapults or taller towers. Alexander had created something unprecedented in the Greek world, a fully integrated war machine that combined cutting-edge technology with lightning-fast mobility and ruthless efficiency. His engineers could dismantle massive siege engines, transport them hundreds of miles, and reconstruct them in hostile territory, faster than his enemies could mount an effective defense. His army moved like a living organism, adapting its tactics to exploit every weakness, overcome every obstacle, and break every enemy that dared to stand in its path. Today, we're going to uncover the engineering genius behind Alexander's empire. We'll explore the revolutionary siege tactics that allowed him to capture supposedly impregnable cities, the innovative weapons that struck terror into the hearts of his enemies, and the strategic brilliance that transformed a regional conflict into a world-conquering campaign. By the end of this journey, you'll understand how a 20-year-old king used technology, strategy, and sheer audacity to build one of history's greatest empires in just one incredible decade. The story begins not with Alexander, but with his father, Philip II of Macedon. While most Greek city-states were content with traditional warfare, Philip had been quietly revolutionizing military technology. He transformed Macedonia from a backward kingdom into a military powerhouse by embracing innovations that others dismissed or ignored. Chief among these was his investment in siege warfare, something that would prove absolutely crucial to Alexander's later success. Philip brought in Polyidus of Thessaly, a brilliant engineer who created the torsion catapult, a mechanical marvel that could hurl projectiles with devastating accuracy and power. This wasn't just an improvement on existing weapons, it was a complete game-changer. For the first time, armies could breach fortress walls from a safe distance, turning sieges from months-long starvation campaigns into swift, decisive assaults. But Philip's greatest contribution was recognizing that siege warfare required more than just better weapons. It demanded a complete rethinking of military logistics, engineering, and strategy. He established the world's first professional corps of military engineers, men whose sole purpose was to design, build, and operate the complex machines needed to crack open enemy fortifications. These weren't just craftsmen or part-time soldiers. They were specialists whose expertise would prove invaluable in the campaigns to come. When Alexander inherited this military machine in 336 BCE, he immediately grasped its potential. But where Philip had used these innovations to consolidate power in Greece, Alexander saw them as the key to conquering the world. He expanded his father's engineering corps, recruited the most talented siege specialists from across the Greek world, and began developing tactics that would integrate these new technologies with his traditional forces in ways no one had ever imagined. Among Alexander's engineers, one name stands above all others: Diades of Pella. If Alexander was the strategic genius behind the empire, Diades was the technical mastermind who made that strategy possible. This man would become known as the one who took Tyre, and his innovations would revolutionize siege warfare forever. Working alongside brilliant colleagues like Tyre and Posidonius, Diades created an arsenal of mechanical marvels that could adapt to any defensive challenge. The lithoboloi, or stone throwers, were perhaps their most terrifying creation. These massive torsion engines could hurl boulders weighing hundreds of pounds with enough force to shatter stone walls and crush entire sections of enemy fortifications. But these weren't just scaled-up catapults. They were precision instruments of destruction, carefully engineered to maximize impact while maintaining accuracy at extreme range. The petroboloi took this concept even further. These were specialized stone-throwing engines designed specifically to counter the heaviest fortifications. They could punch holes through walls that had stood for centuries, creating breaches that Alexander's infantry could exploit with devastating effect. The psychological impact was just as important as the physical damage. Defenders who had spent their lives believing their walls were impregnable suddenly found themselves facing weapons that could reduce those same walls to rubble in a matter of hours. But perhaps most innovative were the specialized siege machines designed for specific tactical challenges. The ditch-filling tortoises, for example, were mobile shields that allowed engineers to approach enemy walls under protection, filling in defensive trenches and clearing obstacles for the main assault. These weren't just tools. They were solutions to specific problems that Alexander's engineers encountered and solved in real time. The genius of Alexander's system wasn't just in the individual machines, but in how they worked together as a coordinated force. His engineers created modular designs that could be quickly dismantled, transported across vast distances, and reconstructed wherever they were needed. This mobility was absolutely crucial to Alexander's success, because it meant he could bring overwhelming firepower to bear against any target, no matter how remote or well defended. Consider the logistics involved. Alexander's siege engines weren't just heavy, they were massive. Some of his towers stood over 150 feet tall, requiring thousands of individual components and specialized materials. Moving these machines required careful planning, dedicated transport units, and incredible coordination between his engineering corps and his regular army. Yet Alexander's forces could break down these mechanical giants, carry them hundreds of miles through hostile territory, and have them operational again within days of reaching their destination. This capability gave Alexander something no conqueror had ever possessed before: the ability to bring overwhelming technological superiority to any battlefield, anywhere in the known world. Enemy commanders who might have felt secure behind their fortress walls suddenly found themselves facing the same mechanical marvels that had already conquered dozens of supposedly impregnable cities. The psychological warfare aspect was just as important as the physical destruction. Word of Alexander's siege engines spread faster than his army itself. Cities that might have resisted traditional forces often surrendered rather than face the mechanical monsters they had heard. Could reduce any fortification to ruins. This reputation for invincibility became a weapon in its own right, allowing Alexander to capture strategic positions without fighting at all. But technology alone doesn't conquer empires. Alexander's true genius lay in understanding how to integrate his revolutionary siege capabilities with his traditional forces to create a military system that was greater than the sum of its parts. His phalanx provided the disciplined infantry corps that could exploit the breaches his siege engines created. His cavalry delivered the swift, decisive strikes that prevented enemies from regrouping or escaping. His archers and skirmishers provided covering fire for his engineers as they positioned their machines for maximum effect. This wasn't just coordination, it was military evolution. Alexander had created the world's first truly combined arms force, where every element supported and enhanced every other element. When his siege engines opened a gap in enemy walls, his shock troops were ready to exploit it. When his cavalry broke enemy formations in the field, his engineers were prepared to capitalize on the confusion by rapidly positioning their machines for the next phase of the assault. The result was a war machine unlike anything the ancient world had ever seen, a force that could adapt to any challenge and overcome any obstacle through superior technology, tactics, and coordination. Now we come to the true test of Alexander's revolutionary system. The siege of Tyre in 332 BCE would prove to be the ultimate demonstration of what this new form of warfare could accomplish. Here was a city that had never fallen to siege, a fortress that had laughed at the mightiest armies of the ancient world. Built on an island half a mile off the coast of what is now Lebanon, Tyre was considered absolutely impregnable. Its walls rose directly from the sea, making traditional siege approaches impossible. For 7 centuries, no army had managed to breach its defenses. When Alexander arrived at Tyre, his generals expected a quick surrender. After all, the city had already agreed to allow him passage and acknowledge his authority. But when Alexander demanded to enter the city and sacrifice at the temple of Melkart, the Tyrians refused. They would honor him as a conqueror, they said, but they would not open their gates. It was a calculated insult that would cost them everything. Most commanders would have bypassed Tyre or settled for a token submission. Alexander saw something else entirely. He saw an opportunity to demonstrate that no fortress, no matter how strong, could stand against his engineering corps. What happened next would become the stuff of legend, a feat of military engineering so audacious that it still seems impossible today. Alexander ordered his engineers to build a causeway. Not a simple bridge or floating platform, but a massive stone and timber road stretching nearly a kilometer across open water. This wasn't just ambitious, it was revolutionary. No one had ever attempted engineering on this scale in the middle of a military campaign. The logistical challenges alone were staggering. Thousands of tons of stone and timber had to be quarried, transported, and positioned under constant enemy fire from the city's defenders. The work began immediately. Alexander's soldiers stripped nearby forests bare, demolished abandoned buildings for their stone, and even tore down old walls to provide material for their impossible road. Day after day, the causeway crept closer to the island city. The Tyrians watched in growing alarm as Alexander's engineers solved problem after problem, adapting their design to counter every obstacle the sea and the defenders could throw at them. But the Tyrians were not passive observers. They launched constant attacks on the construction crews, raining arrows and javelins down on the workers. They sent divers to sabotage the underwater foundations, and they mounted seaborne raids to destroy equipment and kill engineers. The siege became a deadly game of innovation and counter-innovation, with both sides pushing the limits of their engineering capabilities. The Tyrians' masterstroke came when they loaded an old transport ship with combustible materials, doused it with pitch and sulfur, and sent it crashing into the end of the causeway. The resulting fire was so intense, it created what we might recognize today as an ancient form of napalm. The flames spread rapidly, engulfing Alexander's siege towers and destroying months of work in a matter of hours. For most commanders, this would have been the end. The cost in materials and manpower was enormous, and the psychological blow to his army's morale could have been devastating. Alexander's response revealed the true depth of his strategic thinking. Instead of retreating or attempting the same approach again, he completely changed his strategy. He realized that Tyre could not be taken by land assault alone. He needed naval superiority, so he did something that demonstrated the flexibility that made his empire possible. He left the siege temporarily and went to gather a fleet. This wasn't just tactical adaptation, it was strategic brilliance. Alexander understood that his reputation for invincibility was itself a weapon, and he was willing to invest whatever resources were necessary to maintain that reputation. He traveled to every allied city in the region, calling in favors, making deals, and assembling the most powerful naval force the Eastern Mediterranean had ever seen. Ships came from Cyprus, Phoenicia, Rhodes, and a dozen other maritime powers. Within months, Alexander commanded over 200 vessels. When he returned to Tyre, he brought with him not just a navy, but a completely integrated assault system. His engineers had spent the time rebuilding and improving their siege engines, creating new towers that were even taller and more heavily armored than before. His causeway was widened and strengthened, designed to support the massive weight of his mechanical marvels. Most importantly, his naval force could now attack the city from multiple directions simultaneously, preventing the defenders from concentrating their forces against any single threat. The final assault was a masterpiece of coordinated warfare. Alexander's siege towers, now standing over 150 feet tall, moved into position on the completed causeway. His catapults and stone throwers began their devastating bombardment from multiple angles. His navy attacked the harbor walls while his engineers worked to undermine the foundations of the city's defenses. The Tyrians, who had held out for 7 months, found themselves facing attacks from every direction at once. When the walls finally fell, the psychological impact echoed across the ancient world. Tyre, the unconquerable city, had been reduced to ruins by a 24-year-old king and his mechanical marvels. The message was unmistakable. No fortress was safe from Alexander's advance. No wall could protect those who dared to defy him. The engineering achievement was stunning, but the strategic implications were even more profound. The conquest of Tyre demonstrated something that would define the rest of Alexander's campaign. His siege capabilities were not just tools for breaking down walls, they were weapons of psychological warfare that could break the will of entire regions. Cities that heard what had happened to Tyre began surrendering before Alexander even arrived. The mere threat of his siege engines was often enough to secure submission without a fight. But Alexander's engineers were not finished innovating. The lessons learned at Tyre were immediately applied to the next challenge. At Gaza, just months later, they faced a different but equally daunting problem. This fortress city sat atop a high mound, making it impossible to approach with traditional siege weapons. The defenders believed their elevated position made them invulnerable to Alexander's mechanical marvels. Alexander's response was to build an artificial mountain. His engineers constructed a massive earthwork mound, 250 feet high, essentially creating their own high ground from which to attack the city. The siege engines from Tyre were dismantled, transported by sea, and reconstructed atop this artificial peak. Within 3 months, Gaza fell, proving once again that no defensive position was beyond the reach of Alexander's revolutionary siege system. By 332 BCE, word of these engineering triumphs had spread across the known world. Alexander had not just conquered cities, he had conquered the very concept of the unconquerable fortress. His siege tactics had become the foundation upon which his empire was built, each victory demonstrating that traditional defenses were obsolete in the face of superior technology and innovative thinking. The psychological impact was perhaps even more significant than the physical destruction. Entire regions began submitting to Alexander without resistance, knowing that their walls could not protect them from his mechanical marvels. The reputation of his siege engines preceded his army, turning potential months-long sieges into swift surrenders. This allowed Alexander to maintain the incredible pace of conquest that defined his campaign, covering vast distances and subduing enormous territories in impossibly short time frames. But the true genius of Alexander's system was its adaptability. Each siege taught his engineers new lessons. Each challenge sparked new innovations. The modular design of his siege equipment meant that solutions developed for one fortress could be rapidly deployed against the next. His engineering corps became a learning organization, constantly evolving and improving their capabilities based on real-world experience. The siege of Tyre alone had required innovations in underwater construction, naval coordination, and siege tower design. Gaza demanded expertise in earthwork engineering and elevation tactics. Each conquered city added to the collective knowledge of his engineering teams, making them more formidable with every victory. Alexander had created not just a military force, but a technological juggernaut that grew stronger through use. This was the secret weapon that allowed a Macedonian king to build an empire stretching from Greece to India in just 10 years. While his enemies relied on traditional tactics and static defenses, Alexander had weaponized innovation itself. His siege capabilities gave him the ability to crack open any fortress. His engineering corps provided solutions to seemingly impossible challenges, and his integrated military system ensured that every victory led seamlessly to the next conquest. The engineering marvels that Alexander deployed were not just tools of war, they were instruments of empire building. They allowed him to move with unprecedented speed, strike with overwhelming force, and leave behind a legacy of technological supremacy that would influence military thinking for centuries to come. In the end, it wasn't just Alexander's courage or tactical brilliance that built his empire. It was his understanding that in a world of fortified cities and defensive warfare, the side with the best engineers would write the future in stone and steel. Alexander the Great didn't just conquer the ancient world through superior siege tactics and revolutionary engineering. He proved that innovation, adaptability, and technological supremacy could overcome any obstacle, no matter how impossible it might seem. His 10-year campaign remains one of history's greatest demonstrations of how strategic thinking combined with cutting-edge technology, can reshape the world itself.